High voltage circuit breakers are some of the most important components in the substation. The most important task of a circuit breaker is to open circuits under short current condition and thus protect sensitive and expensive electric and electronic equipment. The interruption and the subsequent reconnection should be carried out in such a way that normal operation of the network is quickly restored in order to maintain system stability. Life expectancy of a new installed high voltage circuit breaker is at least 40 years. Throughout its life, under normal circuit operational conditions, it will operate less than 10 minutes. During abnormal circuit operations, it will operate less than 1 minute in its lifetime. There can be various causes of the circuit breaker failure: increased resistance of a main circuit, friction and wear of moving parts, insufficient storage of driving energy in operating mechanism, improper damping devices. Faults can also occur in electrical control circuits. All these defects can cause a circuit breaker not to operate properly when it is needed the most, such as a short circuit fault. DB Power has released a new generation of test equipment for condition assessment of distribution and transmission high voltage circuit breakers. Field portable instruments with standalone or PC controlled functionality allow performing various tests during circuit breaker manufacturing, commissioning and maintenance stages. Applications supported by DB Power circuit breaker test equipment include measurements of timing of circuit breaker main, auxiliary and pre-insertion contacts, synchronization between the phases, contact resistance, dynamic resistance measurement, coil resistance and coil current, mechanism charging time, minimum trip voltage, under voltage release, motion and velocity, first trip test. The CAT series instruments utilize the latest technological achievements in safe and fast testing, with unique technical capabilities of circuit breakers diagnostics. Before connecting the CAT to a circuit breaker, make sure that the circuit breaker is disconnected or separated from its circuit on both sides of the breaker in accordance with the national safety regulations. The circuit breaker is properly grounded to a protected ground. CAT itself is properly grounded. The timing measurement of the mechanical operations is one of the most important tests to determine the real condition of the circuit breaker. Measured values are compared with limits specified by the manufacturer. Timing measurement tests fulfills all the requirements defined by IEC and IEEE standards. Synchronization between the circuit breaker poles has to be within specified limits. Simultaneous measurements within a single phase are important in situations where a number of contacts are connected in series. The free transducer channels are intended for measuring displacement of the circuit breaker moving parts, contact wipe, over travel, rebound, damping time and an average velocity. Well-known Kelvin's 4 points method is used for a resistance measurement. DC current is generated through the closed circuit breaker contacts. The voltage drop is measured between the terminals of the circuit breakers. The resistance is calculated using the Ohm's law. According to the IEEE standard, the minimum test current is from 100 amps DC up to as close as possible to a breaker's nominal current. The IEC standard defines the test current in the range from 50 amp DC to the rated circuit breaker continuous currents. CAT 66 can generate 500 amps during a contact resistance measurement test. Arcing contacts are the most important parts of the high voltage circuit breakers. The arcing contact is the first to make contact during a closing operation and the last to break contact during opening. Therefore, circuit breaker arcing contact wear occurs during normal operation as well as when interrupting fault currents. If the arcing contacts are damaged, the breaker becomes unreliable very soon. Arcing contacts condition cannot be assessed by conventional timing tests, so a new method has been looked into. The dynamic resistance measurement method measures variations in the contact resistance during the breaker operation. When the breaker contact motion is measured simultaneously with resistance, the results can be used to assess the wear or reduced length of the arcing contact. The SAT instrument can measure the trip and close coil resistances. Its measurement procedure generates a very low current through the coil, which would not heat up the coil and consequently increase its resistance. The corresponding voltage drop is measured across the coil and used to calculate resistance according to the Ohm's law. To ensure that a circuit breaker operation is within specification under the most rigorous conditions placed on its tripping ability, the circuit breaker trip coils are specified to work with a minimum tripping voltage much below the nominal battery voltage. The minimum trip voltage test is described in a number of international and national standards. All these tests are performed without changing the lead connections during the test. Essential part of a circuit breaker condition assessment is ability to compare the latest test results with results obtained in previous tests. Measured values are compared with limits specified by the manufacturer. Obtained fingerprint can be used at a later stage as a reference for subsequent measurements. In order to provide accurate comparison, tests need to be performed using identical test parameters. Any deviation and change in test results may indicate the circuit breaker condition deterioration. This ability is supported by DV-Win test plans and graph overlay feature. The final stage of a circuit breaker maintenance process is the DV-Win, providing analytical tools and customized report creation.